Muy buenas noches a toda la audiencia, a todos los invitados que están presentes, a todos los colegas invitados que están en modo virtual. También queremos dar especial agradecimiento a quienes están conectados desde Shanghái a través de la empresa MindPrism. Y bueno, muchas gracias por esta oportunidad de presentar un interesante tema de innovación tecnológica que tenemos en la industria minera particularmente, y que bueno, es parte también de del esquema y la estrategia y objetivos de difusión que tiene la Sociedad Geológica de precisamente promover y difundir nuevas tecnologías en lo que son las ciencias de la tierra, geología, y en este caso aplicado a minería, ¿no? A la industria minera. Queremos dar la bienvenida como Sociedad Geológica del Perú en esta oportunidad primero que nada a la empresa MindPrism, que son la empresa que ha permitido esta conferencia. A través de los ponentes que están conectados de manera virtual, la charla en esta oportunidad va a ser referida al potencial de la robótica y de la inteligencia artificial en la industria minera. En inglés, Potential of the Robotics and Artificial Intelligence in the Mining Industry. Los ponentes en esta oportunidad están ubicados en Shanghái, es lo que entiendo, y uno de ellos es Adam Tutakiewicz, que viene de Londres, está basado en Londres, entiendo, y Kim Su, que está en Shanghái, propiamente tal. Entonces, ellos dos van a ser nuestros ponentes en esta oportunidad sobre este interesante tema de inteligencia artificial, pero a su vez también controversial por el momento en lo que refiere a la aplicación de esta tecnología de última generación aplicada a la industria geológica y a la industria minera. Vamos a entender un poco de qué tipo de aporte innovativo va a generar en la industria propiamente tal. Entonces, Adam es el ingeniero de inteligencia artificial y robótica para MindPrism, y él tiene el cargo de Chief Technology Officer, y Kim Su, que es el siguiente ponente, es ingeniero de robótica de hardware y software. Él es el Chief Engineer Officer para MindPrism. Damos la cordial bienvenida en esta oportunidad a ambos ponentes, y antes que pasaran a hacer su exposición ellos, voy a invitar al ingeniero Mike Benavides de MindPrism para que nos dé una breve reseña sobre esta conferencia introductoria y también sobre los servicios y lo que se trata la empresa MindPrism, que hace posible esta conferencia interesante. Muchas gracias y bienvenidos. Thanks, welcome to Adam and to, King, for having us your interesting conference in artificial intelligence. I hope you can listen to us in a proper way. So thanks a lot for your participation, and good luck for the next couple of minutes. Thanks a lot.
Thank you.
Buenas noches con todos. Primeramente, para comentar sobre MindPrism. MindPrism es una startup que está basada en Estados Unidos. Nació con la visión de contribuir al desarrollo tecnológico en la industria minera a través del desarrollo de robótica avanzada y de inteligencia artificial. Sabemos la gran importancia que tiene la industria minera en nuestro país y en el mundo. La industria minera, en el caso de Perú, tanto directa como indirectamente, está ayudando a 1.2 millones de personas. La importancia de la industria minera a nivel global es enorme, desde el tema de proveer los metales necesarios que son utilizados para desarrollar tecnologías en la industria médica, farmacia, transporte, comunicaciones. Esta misma charla que va a ser vista y está siendo de manera virtual es posible gracias a los recursos extraídos de la minería. MindPrism tiene la visión de al 2032 poder contribuir en la automatización de la industria. Cierto de que está en los límites y Perú está utilizando tecnologías muy competentes a nivel global, siguen habiendo oportunidades de mejora con el tema de la seguridad. MyPrism parte de la visión de poder, a través de la robótica y la inteligencia artificial, contribuir a la minimización y eliminación de estos accidentes fatales y a la vez que optimiza la productividad y reduce los costos operativos en la industria minera. Es un placer para mí darles la bienvenida en esta oportunidad, tanto a los que nos acompañan de manera presencial como a los que nos acompañan de manera virtual. Ahora voy a pasar a dar la presentación de nuestros ponentes para que podamos empezar con la presentación. Adam Tutekiewicz is our Chief Technology Officer at MyPrism, Artificial Intelligence and Robotics engineer from the UK with experience in cybersecurity. Also, he was working for minings, and also for business that have a valuation over $1 billion. He currently co-develops artificial intelligence systems for the transformation of the mining industry and to provide the amounts of resources necessary for the electromobility and energy transformation. And Kim Shu is our Director of Engineering at MyPrism, robotics, hardware, and software engineer from Shanghai, with experience in the development of artificial intelligence solutions, robotics, system design, engineering, and community arms, CNC systems. Adam and Kim believe that the mining industry has the potential to transform the world across the use of robotics and artificial intelligence solutions for the mining industry. Adam, Kim, you can start the presentation.
Hello, everyone. My name is Adam, and I am the co-founder and CTO of MindPrism. Today, I'm joined by Keen, our co-founder and Chief Engineering Officer. Together, we'll be discussing the fascinating world of artificial intelligence and robotics, and how these cutting-edge technologies are shaping the future of mining and our world at large. This is the agenda that today we will go through. I'm so excited to talk about this stuff. I believe it's very impactful and crucial for the world. Mining innovation is essential for the development and sustainability of the global economy and civilization, as it has been a vital aspect of human society since ancient times. Mining has contributed to the growth of civilizations, from the Incas and Romans to modern industrialized nations, by providing resources for trade, artistic expression, and architectural achievements. Today, mining remains critical for the production of a wide range of products and materials, playing a significant role in the global economy and supporting the livelihoods of millions of people. Innovation in mining is important for several reasons. First, market efficiency. Technological advancements in mining increases productivity and reduce costs, leading to more efficient resource allocation and a more competitive market. Price stability. Innovation in mining can help stabilize the prices of raw materials by increasing supply and reducing the cost of extraction. This has a stabilizing effect on the global economy, as fluctuations in raw material prices can impact various industries. Environmental protection. Embracing innovative practices and technologies in mining can help reduce environmental impact of mining operations, promoting sustainable development and resource management. What is important as well is worker safety. Technological advancements can improve worker safety by automating dangerous tasks and reducing human exposure to hazards, leading to better working conditions and more attractive industry for potential employees. The mining industry is a significant contributor to economic growth and development, both in terms of direct economic impact, mining operations, and the indirect impact on the industries that they rely on mine resources. The mining industry adoption of new technologies and practices is vital for sustaining economic growth and development. By increasing mineral supplies and reducing costs, the industry can help meet global demand, support economic activity, and improve living standards. This in turn can lead to increased economic output, job creation, improved livelihoods, reduced poverty, improved quality of life, environmental sustainability through more efficient and responsible use of resources. By investing in innovation and technology, the mining industry can continue to play a critical role in supporting global economic progress and human well-being. Mining is very important for our world. It helps countries grow strong and affects everyone's life. Without mining, we would have nothing. No metals and rocks to build and make things, no energy to move and work, no materials to make goods and products, building homes, building blocks for homes, towns, communities. In short, mining makes our world work. It helps us build, create, and live well. It's the base of our global economy, and we feel its impact every day. One of the most interesting examples of ancient mining is Las Medullas, an ancient open-air mine in northern Spain, once the largest in the Roman Empire. This incredible feat of engineering transformed the landscape and extracted tons of gold. On the right, you can see a gold coins like this, aureus, issued by Nero in 54-57 before Christ. These coins were minted from the gold extracted from mines like Las Medullas. The Roman Empire's mining techniques laid the foundation for modern mining practices. From ancient civilizations to modern times, mining technology has evolved significantly. From manual labor to mechanization, from pickaxes to drilling machines, each innovation has increased efficiency and productivity. In the Las Medullas, the Romans used a technique known as hashing, which is a method of hydraulic mining that uses water to erode the rock. This would be accomplished by using holes to funnel water into the area, thus breaking it up. We can definitely call it mining 1.0. Mostly characterized by manual labor and primitive tools, limited productivity, and of course, safety concerns. Examples of tools such as pickaxes, shovels, hammers, carts, pulleys, and Archimedes' screw. During the Middle Ages, mining underwent significant transformations, setting the stage for modern mining practices. Increased investment in underground mining led to more sophisticated machinery, such as pulleys and winches, deeper shafts, enabling access to richer ore deposits. Water and horsepower used for draining water from deep shafts, powering machinery. Interesting new techniques introduced during this period include acid parting for separating gold from silver, 14th century. Widespread adoption of improved methods led to signs of recovery after the mid-15th century. When it comes to metallurgy and mining tools in pre-Columbian America, ancient civilizations like Aztecs, Mayans, and Incas developed sophisticated metallurgy techniques, crafting tools and artifacts from copper, gold, and silver. They employed advanced mining methods, including open pit mining, underground mining with shafts and tunnels, use of tools like copper axes, stone hammers, and even obsidian blades. These ancient civilizations' innovation in metallurgy and mining tools demonstrate their remarkable ingenuity and contributions to the development of mining practices. Mining 2.0 introduced mechanization using steam and electric power, increasing productivity and reducing manual labor. Key innovations include steam-powered drilling machines, 1807, electric haulage system, 1820s, pneumatic drills, 1850s, conveyor belts, 1870s. We can talk about major milestones like 1769, when James Watt invents the steam engine, first used in mines in 1775. In 1820s, steam-powered haulage system adopted in British mines. In 1850s, pneumatic drills introduced to meet growing demand for coal and metals. Then, 1870s, conveyor belts introduced to improve safety and efficiency in material handling. 1880s, electric power first used in mines for lighting and ventilation. 1890s, electric haulage systems introduced replacing steam power. And finally, the 90s, widespread adoption of electrical equipment in mines. An amazing time of improvement of mining technology. The modern era mining, let's call it 3.0, introduced partial automation of process and equipment, increasing efficiency and reducing labor cost. We can talk about key innovations that include automated drilling and blasting system, about 1955, increased precision and reduced labor costs as manual drilling and blasting were time-consuming and hazardous. We can date the use of first computerized control systems in 1967 that optimized production and improved safety as manual control systems were prone to human error. Some robotics and even remote operated vehicles, so-called ROVs, about 1978, some research projects, performed tasks in hazardous environment and reduced labor costs as manual labor in these areas was dangerous and expensive. We can mention some sensors and monitoring systems that have been introduced since 1985. Their goal is mostly to improve safety and efficiency as manual monitoring was time-consuming and unreliable. As you can already notice, this so-called modern system have already more than 50 years. Is this finally a time for new significant improvements? There is a new time of improvements now. The new age of mining, Industry 4.0, is a fourth industrial revolution in the mining industry. It is characterized by automation. Industry 4.0 in mining uses machines that can perform tasks that were previously done by humans, such as drilling and blasting. Digitalization. Industry 4.0 in mining uses digital technologies such as sensors, IoT devices, and big data analytics to collect and analyze data and make better decisions. Here we can talk about as well about interoperability. Industry 4.0 in mining enables machines, processes, and systems to communicate and collaborate seamlessly, enabling greater efficiency, even better productivity and innovation. Real-time decision-making. Industry 4.0 in mining enables real-time decision-making, which can help improve safety, efficiency, and productivity. Predictive maintenance. Industry 4.0 in mining uses predictive maintenance, which can help reduce downtime and improve equipment availability. Increase productivity. Industry 4.0 in mining can help increase productivity, which can lead to increased efficiency and therefore profitability. And improve safety. Industry 4.0 in mining can help improve safety, which can lead to a reduction in accidents and injuries. Sustainability. Industry 4.0 in mining can help improve sustainability, which can lead to a reduction in environmental impact. Overall, Industry 4.0 in mining has the potential to bring about benefits, including improved safety, efficiency, productivity, and as well increased sustainability. However, its adoption also faces significant challenges, such as high initial costs, data privacy and security concerns, and the need for workforce training and change management. Is adoption happening smoothly? It looks like the mining industry is not a fast adopting industry like in the past. The mining industry is facing a productivity crisis. According to McKinsey Mineland's Productivity Index, global mining productivity has declined by 28% over the past decade, even after adjusting for declining ore grades and inflation. This is a stark contrast to the Industrial Revolution, which transformed productivity in many industries. But there is a hope. The adoption of AI, so-called artificial intelligence, and robotics can help reverse this trend, improving efficiency, accuracy, and safety, and finally increasing productivity. Let's explore how these technologies can help us overcome the productivity challenges facing our industry. There's a solution to this huge problem. AI, artificial intelligence, and robotics enable mines to reach new depths, extract resources more efficiently, and access previously inaccessible deposits. We can transform safety. Autonomous systems minimize risk, protect workers, and reduce accidents. We can revolutionize our productivity again. AI optimizes processes, predicts maintenance, and streamlines operations. We can finally supercharge our sustainability. AI and robotics help reduce energy consumption, waste, and environmental impact. We believe that the future is here. It already has arrived. embrace AI and robotics to transform the mining industry and create a better future for all. But before we dive into the details, let's gain a better understanding what AI actually is. Artificial intelligence refers to the development of computer systems that can perform tasks that typically require human intelligence. For instance, learning. AI system can learn from data and improve their performance over time. Problem solving. AI can analyze the data, identify patterns, and make decisions. Reasoning. AI systems can draw conclusions and make recommendations. Perception. AI can interpret and understand data from sensors, images, and text. As you can see on the left, AI, artificial intelligence, is not a single technology, but a collection of techniques and approaches that enable machines to perform tasks that were previously thought to be exclusive domain of humans. Now, our Chief Engineering Officer, Keen, battle-hardened robotics expert, he will provide an insightful explanation of the fascinating world of robotics.
Hi everyone, thanks for coming. Next, I will give you some explanations of what robotics are and some examples of cutting-edge robotics. So, what this is Tesla Optimus robots. As you see before, this is a full self-drive car, and it has a bunch of cameras and a bunch of LiDAR sensors on top and a bunch of computer chips calculating and doing the full self-drive. Then they are basically robots on wheels. Now, if you take the wheel off and put on a bunch of arms and legs, they become humanoid robots. Why is this important? Because our daily life, everything is built around people. Like the doorknob, that's for people. And a lot of other object handling, how to drive machine, all that kind of thing, it's for people. So a human-shaped robot, it's the best robot for general tasks to replace a bunch of repetitive, boring, dangerous tasks. So at the left, it's their beginning concept. And a couple months later, they have some prototype. And a couple years later, they have huge progress on the robots. And next, I will show you their latest version and how that looks like. So this is their latest robots. This video has only been released like 3 days ago. You can see the robot is picking up the batteries. That's their front truck. There's the knee. Gently back. There's a lot of people. They're standing next to the robot. They're actually remotely controlling the robot, training, providing data to the robot. And hopefully in the future, they can fully self-drive the car. This office is and this is what we'll do next one. All right. So this is the Tesla robots. Like their cars. Right now, Tesla Full Self Drive is around the corner. They're almost deploying to the customers. Like those self-drive cars, they're already in the streets, and they're 10x safer than human driver. They never be tired, never don't have to sleep. Like never lose any attention. Always be fully careful to the road. So it's a lot safer, a lot cheaper, and a lot faster. And hopefully like they can be mass produced and deployed everywhere in the factory to reduce those boring tasks, dangerous tasks. All right, next I will show you some example of robots replacing those dangerous tasks to make human more safer. So this is an example of a glass washing robot. This is before people have to climb up, use ropes, very, very dangerous, and cleaning those high-rise buildings glasses. And this is AI-powered glass washing robots. And this is how they deployed, very fast and easy. And that's remote controller. Those are the water pipes. Yeah, it can just go against gravity, have some vacuum sucks, so we'll stay on top of the building, won't fall off. And it has AI built in, so it can automatically scan the whole building. You don't have to do much of control. It can do the job itself. Yeah, and also have very interesting design, so it can go through gaps, go through obstacles, all that kind of thing. Like this, very cool. It can even go through the corner, rounded glasses, all that kind of place. All right, so that's example video of those AI-powered robots replacing those dangerous jobs, make humans safer, make the whole thing easier, make life better. This is a Chinese startup company, I believe, and there's lots of other similar companies doing these kind of innovations, replacing dangerous jobs like cleaning those windows and a lot of others. And with a little bit of modification, those robots can also work under the mine, replacing humans for dangerous places to do some detecting, to do some cleaning, or that kind of thing. So this is an example. Next, I will show you a next example of how robots replacing dangerous jobs to make humans safer. So this is the Spot robot dog from Boston Dynamics. You've probably seen this everywhere on the internet and on some conference. This is an example of the robot dog doing some examination under a mine. So he is trying to explaining how the robot dog works and how this mine is. It's very deep underground mine, very, very deep. So this is a cloud scan, what you just passing by. It's scanned by this robot dog. It's come from its LiDAR sensor on top. The unique design of robot dog, the legs, allow them to go through very challenging terrains. Unlike wheel, they can go to all kinds of random places. It's very good for underground mining condition. Yeah, also work on the water too. Yep. You might be able to see there's a spinning little disc on top of the robot. That's the LiDAR sensor. And this is a drone, also does 3D scanning. underground harsh condition. Just after blasting might be dangerous for human to go, and robots is perfect for this task. Yep, here is workers doing inspections before they go. Yep, do some scan. You see this spinning thing on top of robot? That's a LiDAR. And task finished, go home. All right, so this is an example video of this robot dog doing dangerous works in underground mine, helping humans help them to be safer. Yeah, so next, there's another recent trending example. This is also another underground mine. This is in Xinjiang, China. This video is on viral half a month ago, something. So what this is basically a remote controlled driller underground. Yep. Again. So he is controlling remotely of this driller to break some rocks. The mine is about 500 meters underground, and it's quite dangerous. And if there's a big rock problem, before this machine like might not have to go underground and manually do those tasks, and it's quite dangerous and take a lot of time. Now they can just simply remote control them safely in a nice office building. And yeah, that's an example of how robots help humans be safer and more productive and faster. Okay, next. This is a Sandvik fully autonomous underground driller. This video is released about a year ago. You see that's a LiDAR. This is a camera. A lot of sensor input. And this allowed the robot can do full self tasks. This is a control room. She has tried to give the machine some task. That's the underground map. Assign some points. That's the targeting point, and this is the start. And the machine just goes. You don't have to control them. Fully self-controlled, like those full self-drive cars. Avoid obstacles, self-deploy, and now start to drilling. Those plans probably self-generated too. The whole time there's no human in the underground mine. Maybe some inspectors, but you don't have to go to where it's drilled. It's very safe for human. Fully autonomous. No human control. Now job done. The machine gets back to where it's began. Do some charging. Ready for next job. Task done. All right. So this is another example of robotic and AI combined. Increase mining productivity, increase safety, reduce cost. All right. Next.
In the context of mining, AI can be used to analyze data from sensors and equipment to predict maintenance needs and optimize operations. Optimize processes such as exploration, extraction, and processing. Improve safety by detecting potential hazards and alerting operators. Enhance decision-making by providing insights and recommendations. AI is a game changer for the mining industry, and it's essential to understand its potential and limitations to harness its power effectively. Now, once again, our Chief Engineering Officer will show the real-world application of AI, providing a unique and insightful perspective on the subject.
All right. This is our product, Rocky AI. This has cutting-edge AI system and a lot of advanced coding. And what it does is basically analyze the rocks after blasting, their size distribution, bigger rock or small rock, how many super big rocks, if they're gonna stock the crusher, all that kind of thing. So before this type of software, you have to send samples manually to lab to do analyze, which is take a lot of time and cost a lot. And you can't do too many analyses at one day. And yeah, so like basically you cannot know very accurately how good the mining blasting is. And there's no way you can optimize it very goodly because the cycle time is very hard. Then current software in the market, they require manually draw out most of the rock shapes. They use legacy, relatively old algorithms to detect shapes of rocks and take a lot of hours. 10 minutes to 1 hour per image. And if you want to do 10 image analyze, that would take a day. A lot of time. So our system, fully autonomous, AI-based, automatically detects the reference object, automatically detects all the rocks. You don't have to do anything. You just upload them and it's done. We have a couple different versions. For mobile version, just upload them. If you after blasting on site, you just upload from your phone, and within 30 seconds, the analysis is done. Super fast. And as you can see, the quality is amazing. Like those are beautiful rocks. Almost every single rock is detected. And if you don't have internet, just take some pictures, go home to the office, and upload some images, and done. We also have other versions for conveyor belt. For example, it's running 24/7 on top of conveyor belt, monitoring the rock distribution and the volume of rock, how many they passed, and you can do quick analysis. And also it can help reduce crusher power consumption and optimize crusher settings, make the rock size more even. Crusher takes huge amount of energy in the whole mine, and it costs, have a big portion of the cost in mind. So reduce that will help a lot, reduce the cost of the mine. And also with this data, now you can improve the blasting design. You can, based on the rock distribution analyze, reduce the cost of blasting material, make it less. And also, meanwhile, reduce the big rocks, because big rocks will stuck conveyor belt, will stuck crusher, which will cause a lot of issues in time. Here are some examples. This is one image. That's the input to reference object, some rocks. And this is the analyzed data. Automatically detects the reference object. You don't have to do anything. You just automatically do the job. And the rock color is based on its size. The bigger, the more red. The smaller, the more blue. We know exactly each single rock, their size, their volume, their diameter, all that kind of thing. This image is P80, which means 80% of the weight of the whole rock distribution. The green one in the image, that's P80 rock. So you can clearly see how big P80 rock is. And the bigger than that, it's bigger than P80. Smaller, less than P80. Very straightforward visualization. Here's some of the plot. We have a lot of different types of plots. This is one of the diameter accumulated plot. So from P1 to P100, all the way have in diameter, the volume, and the curve. Next, this is accumulated by weight. This is how lab measures the P80 data. We have above 90%, sometimes 95% accuracy of analyze, and we have lots of different type of data to give you more insights and a lot of data. And also, we also have truck version, which is a big stand on top of truck. When truck passing by, we monitor the volume and other characteristics for analyze to improve efficiency. We also have shovel data. We can put camera on top of shovel. So basically each scoop will analyze their volume, their time to reduce cost and analyze those rock size, all that kind of thing, which will help mine reduce cost a lot and improve efficiency a lot. That's some examples of right now AI will help mining to reduce cost and improve efficiency. Next.
By advancing mining technologies on Earth, we are paving the way for the realization of the space mining and bringing it closer to reality. And there are some opportunities that come with that. Unlimited resources, access to virtually unlimited resources such as water, metals, and rare earth elements, which could fuel human progress innovation. In-space manufacturing, ability to manufacture goods and materials in space, reducing the need for transportation from Earth and enabling new industries. Space-based energy, potential for space-based solar power and other energy sources, providing a sustainable and abundant energy alternative. New markets and industries, creation of new markets and industries such as asteroid mining, space tourism, and in-space manufacturing. Improved technologies, advancement in technologies like propulsion, life support systems, and robotics, which could benefit Earth-based industries as well. The key to making space mining economically feasible lies in overcoming the challenges associated with the high cost of launching materials into space and the significant investment required for mining operations. As technology advances, the cost of space launchers is expected to decrease, making it more economically viable. For instance, reusable rockets developed by companies like SpaceX aim to reduce the cost of payload to orbit significantly. Asteroids are a prime target as they are rich in resources like water, metals, and rare earth elements. These resources can be used to fuel human exploration and settlement of space, as well as the support of Earth-based industries. Mars mining is also gaining attention, with its abundance of water ice and helium-3, a rare isotope of helium that could be used as fuel source for fusion reactors. Mars resources could support human settlements and fuel further exploration of the solar system. Many companies are already working to develop the technologies and the capabilities needed to extract resources from space. SpaceX, funded by Elon Musk, is also playing a crucial role in advancing space technology with its Starship program aiming to establish a permanent human settlement on Mars. With the potential to access virtually unlimited resources, space mining could be the key to unlocking humanity's full potential in space and mining. That's why our company MindPrism is working on something new to accelerate the space mining. By 2032, MindPrism envisions a futuristic autonomous mine where artificial intelligence optimizes entire operations, leading to reduced costs through efficient resource allocation and predictive maintenance, improved profits via enhanced productivity and optimized decision-making by AI. Enhance safety by minimizing human intervention and predicting potential risks. In this mining 5.0 era, the next stage of mining, AI-driven management will revolutionize the industry, setting a new standard for sustainable and technological advanced mining practices. We envision a mining operation that functions as unified entity, akin to a single cell or a computer chip, where AI makes the most effective decisions and the robots execute the hard work seamlessly. To take advantage of the new digital age in mining, it's crucial to embrace digital transformation in automation. Here are the key ways to leverage these technologies. AI and robotics can be used to handle dangerous tasks and minimize human exposure to hazards, significantly improving safety for workers. Automation and AI can optimize operational efficiency by streamlining processes, reducing downtime, and extending equipment life. Digital technologies can help optimize energy consumption and reduce waste generation, contributing to sustainable mining practices. AI and machine learning can analyze vast amounts of data to provide better decision-making and operational insights. Encourage cross-functional teams to understand both mining operations and the technologies involved, fostering collaboration with the technology providers for tailored solutions. Train employees to work alongside AI and robotic systems, and develop new roles and skill sets to manage and maintain advanced mining technologies, ultimately benefiting the companies, the people, and the environment. Imagine a world where mining has been completely transformed by artificial general intelligence, leading to a new era of efficiency and sustainability. With artificial general intelligence, mining operations are optimized through real-time data analysis, predictive maintenance, and autonomous systems. This not only increases productivity, but also makes the industry more eco-friendly and human-centric. AGI can take over dangerous tasks and minimize human exposure to hazards, making the mining industry much safer for workers. Plus, AGI can learn and adapt to complex environments, ensuring continuous improvement in mining practices. Overall, the integration of artificial general intelligence in mining operations can and for sure will revolutionize the industry, making it safer, more efficient, and more sustainable. It's exciting to see how AGI can contribute to a better future for mining. Thank you very much for your attention. Now it's time for questions and answers. Please scan the QR code to ask us a question.
Hacer las preguntas, si pueden volver a presentar para que escaneen el código QR y a través del código dejar su pregunta. ¿Tiene una consulta? Adelante, adelante con su consulta.
Gracias, gracias Adam, Kim, por su conferencia, por sus palabras. Y bueno, la pregunta va para si nos puede ampliar las razones de esa reducción en productividad que registra Mine Length Productivity Index, el índice de productividad en 3.5% por año. Si nos puede ampliar si eso es estrictamente por un tema de improductividad de equipos y de mano de obra, o es una improductividad por cuestiones de profundización de la mina, mayor profundización de las minas, o agotamiento de las minas en provisión de mineral. No sé si puede complementar algo al respecto, ¿no?
Adam, King, the question is if you can talk more about the 3.5% that are decreasing in the productivity of the mining in the charges you shared before, and maybe if the cause of that is the mines are more and deeper, or maybe it's for the productivity of the equipments. Why? What causes is the reason? What is the reason that this 3.45% of minus productivity every year? If you can talk more about that, more details.
Yeah, if I can complement that, if that the reason of that decline in productivity index, is it because of the mines are getting deeper, or depletion of ore at the mines, or is it strictly related to less productivity of equipment and labor, things like that?
Thank you very much for the question. And yeah, that is an excellent question. I believe this is a huge problem. And actually, there is no one precise answer to that. There's a lot of variables, a lot of factors that contribute to this significant drop of productivity according to McKinsey research. But what we believe is this is a problem caused by basically the operations are much more widespread than before. The managements are getting more complex. There are a lot of bottlenecks in the daily operations that sometimes pause the work for a significant amount of time, and the repairs are delayed. The equipment is not changed on the time, and the introduction of the new technologies sometimes to the wider sites is a little bit chaotic. So it happens in just one part without the full integration of the rest, which actually it doesn't give the benefits straight away, and this time for adoption it takes out as well some part of the efficiency. It's a complex problem, and I think all of us can blame bureaucracy for that as well. It's the mining industry, especially on the management side, grow very vastly in the recent years, and hierarchical the structure of the big mining organizations makes them to make decisions even slower, and that impacts the productivity, where they are the bottlenecks that has to be solved very quickly, very fast, and sometimes this takes months. So personally, I believe this is one of the main issues that create this complex problem. Yes, any more questions?
Thank you, Adam. También quiero aprovechar el espacio para hacer un llamado a la acción respecto a los proyectos que están trabados en la industria minera. Para hacer un comentario al respecto, ya hemos visto en la historia cómo ha pasado la pérdida de la extracción o de la puesta en valor de recursos en el Perú. Por ejemplo, en la época del guano, en la época del salitre. Cuando llegue la minería espacial, es muy probable de que también se hable en la historia de una pérdida de la oportunidad de poner en valor los recursos minerales. Ya ha pasado antes y puede volver a suceder. Hay miles de millones de dólares que están trabados en proyectos y que de acá a 10, 15 o 20 años, dependiendo cómo avance la industria espacial, con un solo asteroide de oro, de cobre, pueden tener más tal del de las minas que se podrían extraer acá en el Perú o en Chile o en el Congo. Entonces, es muy importante que se ponga en valor esos proyectos lo antes posible para poder aprovecharlos. Que no sea de acá a 20 años, 30 años de que se hable de que oportunidades como el guano, como el litre, como la minería metálica se desaprovechó en el Perú. Para comentar eso y hacer un llamado a la acción a nuestras autoridades, que vean de una manera más concreta posible cómo acelerar este destrabo de esos proyectos mineros que ya de por sí los que están en marcha agregan enorme valor a la comunidad peruana. Como se mencionaba, 1.2 millones de personas directa e indirectamente en el Perú beneficiadas por la minería. Si dejamos pasar esta oportunidad de la minería, quién sabe de qué otra industria irá a vivir el Perú de acá en los siguientes 20, 30 o 50 años. El momento es ahora y la robótica junto a la inteligencia artificial nos proveen la capacidad para poner en valor esos recursos de manera más rápida, eficiente y amigable con el ambiente. Es el momento de que tomemos y tomemos conscientemente la acción al respecto. Gracias. Thanks, Adam, King. We will send you more questions if we have. We will share the link and the QR. Thank you very much.
Thank you too.
Thank you very much. It has been a pleasure to be here.
Thank you. Thank you. Thank you. Thank you.
Bueno, muchas gracias a la empresa Mind Prism y a su representante que está acá con nosotros, Mike. Gracias por permitirnos conocer un poco más sobre esta nueva tecnología que va a contribuir poco a poco en el desarrollo de mayor productividad en la industria minera y seguramente en otras industrias también, progresivamente. Iremos conociendo poco a poco, de la mano con la Sociedad Geológica del Perú, qué tipo de servicios y qué tipo de innovación en servicios puede entregar Mind Prism en adelante, para ver cómo podemos establecer una buena relación institucional que permita exponer estas tecnologías y estos resultados productivos. Será interesante quizá más adelante que se pueda dar una exposición muy corta sobre algún caso práctico de la aplicación de la inteligencia artificial y el servicio que pueda estar dando Mind Prism en alguna operación, no necesariamente en el Perú, pero en algún lado del mundo, ¿no? Entonces, muchas gracias por su participación y por su exposición a través de los amigos que están en Shanghái. Gracias a todos ustedes por su presencia, y si tienen preguntas, lo dirigen por favor al correo electrónico de la Sociedad Geológica del Perú, para a su vez pasarlo respectivamente a los conferencistas. Bueno, en este ciclo de conferencia del día de hoy también está programado la charla del equipo ganador del Explora Perú versión 2023, y entiendo que está el equipo presente para hacer su exposición el día de hoy, y el tema que va a presentar a la comunidad de geología y a la sociedad geológica es una visión multidisciplinaria y multiescala para la prospección de sistemas minerales ocultos en los paralelos 13.5 grados a 15 grados. Y el expositor que tenemos en esta oportunidad es el bachiller, colega nuestro, Brian Yari Castillo Requis.